Welcome back. Now, if you remember, I said that there's a couple of cases where the table would probably not work for you. It might work partly, but it might not work completely. Okay, so I'm going to still bring back the table. Okay, there's the table. Okay, now how you assign priorities won't change. Okay, whether the table works or not. Like I said, there may be a problem or two on the test or quiz or homework that probably is a case where the table doesn't work. But like I said, the way I told you this is probably one of the 1% of the easiest ways among the million or zillion ways this is probably taught, right? The remainder of those 99% is probably very confusing and probably doesn't lead to correct results most of the time. All right, so this is just that one exceptional case. Even if you don't want to remember this and say, I'm going to skip this question on the test, by all means do. But I want you to understand it even if you want to skip it. Okay? All right, with that said, we're going to assign priorities. This is an iodine. Clearly, this is the carbon. It's attached to an iodine, so that's one. This carbon's attached to a carbon, and then a bunch more attached to that carbon, and a carbon attached to a carbon, which is attached in turn to 3 hydrogens. This carbon is attached to hydrogen. Now we know that this is our number 2, this is our number 3, this is our number 4. Now, if you notice, okay, let me get my pink color here. If you notice, the sequence is 1, 2, 3, which is not a problem. Right? So that is clockwise. But you notice that the lowest rank substituent is neither front nor back. Right? Right? So what do we want? Where do we want our lowest rank substituent? It's got to be in the front or the back. But here it's in the plane of the paper. Whenever you see a line, that means these two are in the plane of where that white surface is. The CH2, CH3 is coming towards you, that is sticking out of the plane towards you, and the I is sticking away from you, that means out of the plane behind the white paper, right? So we don't have our lowest rank substituent neither in the front nor in the back, okay? There's 2 ways you can do, okay? First, let's keep it open-ended, all right? Let's say we swap with the iodine, that means let's rewrite this, but this time around, let's write the iodine in, typically you want your bigger group, the highest priority, to be normally in the plane because it's pretty heavy, so you want it to be in the plane. So our logical swap would be to bring the iodine where the hydrogen is and then move where the hydrogen is to the back position where the iodine was. The reminder, draw them as it is, okay? We're doing a little experiment here on a piece of paper, all right? That's essentially what we have done. Now, let me explain my decision. Iodine gets the highest priority, okay? That has not changed, right? And fourth is hydrogen is the lowest priority. Typically, you want your highest priority to be in the plane of the paper. That is, you could have swapped with CH3, but then our goal is to get the hydrogen to the front or back position. Since iodine is in the back position now, but we want iodine to be in the plane of the paper, that means our first ideal swap would be to take the hydrogen, put it in the back position, bring the iodine back to where the hydrogen was. Now let's assign priorities. So that means this will be 1, 2, 3, and 4. So what does that mean? That means that we have a clockwise rotation, right? And the hydrogen is in the back position. So clockwise back is R. Let's say, what if we didn't swap the iodine, but let's say swap the CH2, CH3. See what result do we get. So let's get keep in mind the hydrogen has to go to the front or the back. So whatever was in the front or the back position currently should go to where the hydrogen originally was. So this time we're going to leave the I alone. And instead of the hydrogen, we're going to swap the second highest priority, which is in the front position. We're going to bring that over here and move the hydrogen to the front position. All right? And then our CH3. Now, this is not how it's taught. It's just it's taught so complex that it seemed like there is no one way you can solve this, and students get really lost in the process, and they have no idea after a couple of problems that they seem to get everything wrong, and then they're flustered at that point, like, okay, I just don't know how to do it. This is probably the best way to get this kind of compounds right, okay? At least to my knowledge, I've done this for a long time, and to my knowledge, I think this seems to make sense. Now go ahead and assign priorities 1, 2, 3, and 4. Now connect 1, 2, 3. The only logical way I can connect them is counterclockwise, and then the hydrogen is in the front, so counterclockwise, front is R. Now how magnificent is that? If you look at the key, they may have done one of this, and then they will tell you R, okay? And you would wonder, how do they know it? He didn't use the table, and the way they may have taught may work for that particular example, but the moment you branch out and try a problem in the back of the book, or something you found on the internet, or some practice worksheet or practice quiz you found on the internet, well, guess what? It's not going to work, and you're going to be flustered. Okay, that's because the way it's typically taught doesn't apply to a lot of the cases. What I'm teaching you applies to a lot of the cases, and it's going to work. Okay, whether I swap the iodine for the hydrogen or the ethyl group for the iodine, I get the same exact answer. Do you see? I mean, I got R. I don't need any more evidence to convince you that my method works just fine, right? Because we typically don't swap anything that's already in the plane of the paper, because technically it's already in a much stable position. You don't want to move. So you could have argued, hey, could I have swapped the methyl? Why would you want to? It's already in the plane of the paper. It's already in a much stable position. So that means you don't want to move it. Now, all these are very abstract. So this is the only case where you try your table and apparently you see your number 4 is not in that position, then we have a problem, okay? So now we have R as our answer, right? Yes, that's correct. So however you look at it, it's working out just fine, right? So this is an R, right? This is an R, this is an R. Whichever way I swap, I seem to get the right answer, right? Very good. So this is one of the few cases where that rule, this table is of little use. But again, I'm not going to test you entirely with this or entirely where the table is used. I will have a mixture of both, but you can count on that I will not test too much of this, because typically on a professional exams you test, they don't really test too much of the exceptions. They usually test the straightforward ones. So anything we've seen until this video is pretty much straightforward and draws directly out of the table, right? So this is just that one case where, things just obviously don't fall in place, right? Very good. So that is how you do, that's how you do a compound that does not typically fall in place. All right. Now, when I come back, I'm going to talk to you about something that is also just as important as anything you've seen in the first 2 videos here. All right. So stay tuned for more videos, and I'll see you soon with another video.